All right, our starter today. So go over the questions one more time with you. Number one, when your coffee gets cold, it's because cold invaded the coffee cup. Number two, the measure of heat energy, joules, calories, or rads. Number three, if your coffee loses 10 units of energy, then the air around the cup must A, also lose 10 units, B, gain 10 units, or C, gain 100 units. Number four, what is the meaning of triangle T? And number five, if the initial temperature of water is 35 degrees Celsius and the final temperature is 65, what is triangle T? All right, I'm going to switch us over here to do some Apple TV and my iPad. And there we go. All right, so let's get after this. Number one, asking about if coffee, so if your coffee cup right there, with the handle kind of on it there, and yeah, the heat kind of goes, where does the heat go to? The heat goes out. Heat energy leaves, okay? Cold does not go in, heat energy comes out. And so cold does not invade your coffee cup. That one is false. Number two, the measure of heat energy. We have two different measures. You might even remember from last year that joules is one of our measures, and the other one is calories. Calories, similar to food calories. We'll talk about that relationship in a bit. But yeah, joules and calories. So we have two right answers there, A and B. Rads, keep in mind that was all about radiation. Okay, we don't want that right now. If your coffee loses 10 units, so up here, if it lost 10, and let's say it was joules of heat energy came out, well, remember, conservation of energy. You cannot create or destroy energy. So if 10 joules of energy leaves your coffee cup, the air around it must gain. So it is gain 10 units of energy, whether that is in joules or in calories. All right. Number four. Number four, what is the meaning of this thing, triangle T? Well, the symbol, that one right there, means change. Delta is the symbol. It means the change, and this one right here, you probably guessed that one, temperature. Temperature. And we always do it in degrees Celsius for the work we're going to do in energy right now. So it means change in temperature. All right, and we're always going to do that delta T is going to be the final temperature minus the initial temperature, okay? Final minus initial. We always do it that way. What we ended up with minus what we started. All right, so in number five, we said that the temperature initial was equal to 35 degrees Celsius, and the temperature final was equal to 65 degrees Celsius. So when you look at our equation there, delta T is going to be equal to temperature final minus temperature initial. So our final temperature, so delta T is going to be equal to 65 minus 35. So delta T is going to be equal to 30 degrees Celsius. Okay? All right, and that's the final answer. Delta T, temperature final minus temperature initial. And it's important to get it the right way because we can have negatives, all right? So in other words, if the final temperature is lower than the initial temperature, we get a negative change, and we want to be able to keep track of whether it's positive or negative. That becomes important as we move forward. So always be sure, delta T, final comes first, okay? Final and first. All right, let's move on with a little bit of practice about how we actually use some of these things and actually begin to calculate the amount of energy that changes in or out of a system.